Here's a problem on the area between curves from section 6.1 of Rogowski's book. That's page 339 we're on. I want to do problem 39. Notice the instructions say, sketch the region enclosed by the curves and compute its area as an integral along the x or y axis. So what I have is x equals y cubed minus 18y and y equals 2x, y plus 2x equals 0. So I guess the first thing we've got to do is sort of think about these two curves, figure out what on earth is going on. This curve right here, I guess we could write as y equals negative 2x. That's probably the easiest way to plot it. So has a slope of negative 2x, goes through the origin. Or because this seems to be a function in terms of y, we could write this as x equals, say, negative 1/2 y, right? So notice that this is a function also if y is 0, x is 0, so it goes to that point, but we first off need to know where do these two functions intersect, saying functions in terms of y, so we're kind of looking at it sideways, right? So the way you do that is you set them equal, so x equals x, points they intersect, x equals x. So what do we have here? I have negative 1/2 y equals y to the third minus 18y. Getting it all to one side, 0 equals y to the third minus, you could say, let's say I'm adding a half, so you could say 17.5 or 35/2 y. Okay, and if you were going to solve that, I'd probably factor out a y, so y squared minus 35/2. Then this piece factors, it's the difference, I mean, if you think about it creatively, it's the difference of two perfect squares, right? So it's y minus the square root of 35/2, y plus the square root of 35/2. Square root of 35/2 is, you know, there's a positive value up here, there's a negative value up down there. So somehow or other this intersects this line three places. How do you kind of figure out whether this is bigger or smaller than this? Because integrating, if we're going to find the area, we kind of need to do the bigger minus the smaller. Well, since this is a function in terms of y, what you might do is you might just plug in a y value. So for instance, if you plug in 1, the y value 1, notice here if you plug in the y value 1, x is negative 1/2. If you plug in the y value 1 here, so when y is 1, x equals 1 minus 18. So that's negative 17. So this might be a little bit negative. This function is very, very, very negative, right? So it's at y equals 1, it's at negative 17. So this sort of swoops down like that. It swoops up like that. Now, you might actually notice that these both seem to be symmetric about the origin, right? We have odd powers of y there. But even if, and that probably means the area of these two things are actually the same, but even if we somehow got the order wrong, we just keep our eyes open, and if you integrate and you get a negative area, obviously you got the wrong function larger. So we are going to integrate here. I'm going to start at y equals negative square root of 35/2, go up to 0, with this being my larger function, so y cubed minus 18y, this being my smaller function, right? That's my smaller function, so minus negative 1/2 y. Okay, so that's this area here. Now you could sort of plus, we got the other integral right there, right? But you could obviously combine the linear terms, so this is negative root 35/2 to 0, y cubed minus, and again, it's negative 18 plus 1/2, which is 35/2. So negative 35/2 y dy. The interesting thing about the other piece is always, if you're just switching them, right? You're just switching which one's positive and which one's negative. So essentially, you can just sort of switch the signs, right? So you could just say negative 3y plus 35 over 2y. And this piece is going from 0 to positive 35 halves. Okay, so this is a pretty easy integral to do. 1/4 y to the 4th minus 35. Since it's y squared, we're going to be dividing by 2, so let's say 35/4 evaluated from negative root 35 halves to 0, plus, same thing here, negative 1/4 y to the 4th plus 35 halves y squared evaluated from 0 to root 35 halves. Okay, so the interesting thing is you plug this in and everything actually gets surprisingly nice. We have 1/4 times, let's see, squaring this just gets us 35 halves. The 4th power is squaring it again, so it's basically 35 halves squared minus 35/4 times this thing squared, which is 35 halves. Okay? Now what do those two things come together to be? Notice the numerator of both is 35 squared. 35 squared. The denominator here is 16. So 35 squared 16ths minus 35 squared 8ths. Now, what happened here? Because I really think this should come out positive. So here, notice I've got 16ths minus 8ths. That should be 8ths minus 16ths. Oh, wait. I should have taken 0, right? I evaluate this at 0. I get 0 minus this quantity. Well, that's a good thing. So 35 squared 16ths minus 35 squared 8ths. So if you have a 16th minus an 8th, that's negative a 16th. So we have minus negative 35 squared 16ths. And that's a positive. This better be a positive area because remember the shape up here is a positive area. Now we'll play the same game over here. Better come out to the same area. That's because this shape is symmetric, right? So plug in 35 over 2 square rooted into the 4th power. Again, you get negative 1/4, 35 halves squared, plus 35 halves times 35 over 2 squared. So we have 8ths minus 16ths again. Here it's minus 0, right? So what do we get? Again, we get 35 squared 16ths. So you add a 16th and a 16th together. You get 2 16ths, so we're an 8th. So 35 squared 8ths. Or we could write that down as 12/25 8ths. There you have it.